In this video, I want to discuss the difference between irrational and rational numbers. Irrational numbers are pretty simply things that are not rational. Ir meaning not, so literally the word means not rational. We also have the phrase that someone's acting irrational. We think they're acting not logically, kind of crazy, and these numbers are kind of crazy. They're numbers that we cannot write as quotient of integers, which is a fancy way of saying they can't be written as fractions. When we look at their decimals, we're going to see decimals that do not stop and do not repeat. So here's some examples of irrational numbers. Note some of these are pretty famous numbers that have symbols. Pi, for instance, we use a lot, so we can't write it out because it's irrational, so we have to use a symbol. So anytime you see symbols like square root signs, those are going to be irrational numbers. We also have phi and e that are also useful in math. Phi we talked about with the Fibonacci numbers. It's the golden ratio. If you notice, all of these decimal places do not stop. They all have the little ellipse on the end, meaning they keep going. And none of them have a pattern. There's no repeating to them. So if you look, all of these have different numbers in each one of the digits. Here, square root of 2 looks like it might start having a repeating with the 1, 4, 1, 4, but then it has 2 to switch it up. Down here in the last example sometimes throws people off. I use just 2 numbers, but it's never the same thing side by side. So I've got 1, 2, then next I have 1, 2, 2. So it's not 1, 2, 1, 2, 1, 2. That's what we mean by repeat. The opposite of these irrational numbers are rational numbers. Remember from the last video that these are things that can be written as fractions. So we might see them in that form, or they might be decimals that we know how to write as a fraction. For instance, 0.5 we know is 1/2, or 0.1 is 1/10. If we're looking at their decimals, that means they either stop or they are going to have this repeating going on. If you remember back to middle school, anytime you use a little bar over decimal, so 0.3 with a bar on top was 1/3, that's what we mean by repeating. So some examples of rational numbers, like I said, 0.5, that's 1/2, 3/4, 1.78, that one stops, it terminates. Here's our 1/3, our repeating decimal. Then we have 0.456, 456, 456. That's also repeating. The same number, 456, keeps getting copied and pasted over and over again. And then last, we have something that looks kind of long, but it doesn't have an ellipse on the end, so it stops, which means it automatically must be a rational number. One way that I like to think about it are irrationals are the weird guys. Everybody else is rational. So irrational numbers have to first have an ellipse on the end, and second, they can't have any of this copy-paste pattern or repeat on them like 0.3 does or 0.456. So those two things need to be met to be irrational. Everything else is going to be a rational number.